Okay, this video is a short tutorial on basic partial fraction decomposition. Long name, but partial fraction means I'm going to take a fraction and I'm going to break it apart into partial fractions. And decomposition means you break apart. So basically the first step with any partial fraction problem is if you're given a denominator and it's not factored, the first thing you want to do is factor it. So the way to factor this, I think what we can do be x minus 4 times x plus 1. Now, people factor in different ways. A lot of the times I think in my mind, the diamond. And I think basically what two numbers multiply together to give me -4 and add together to give me 3. So the first thing I think of is -4 and 1. Multiplying them, I get -4. Adding them, I indeed don't get 3. So I should change this to a plus and a minus. In that case, adding them, I would get +3, and multiplying them, I would get -4. Okay, good, we get that fixed before we went any further. So now, partial fraction decomposition takes this equation and decomposes it into two fractions, partials. So what we want to do is we want to now decompose this into some fraction that has an x minus 4 denominator, or sorry, x plus 4, and then x minus 1. Now we don't know yet what's going to go in the numerator. So what we do is we just pick two unknowns. Let's call them A and B. Unknown numbers that are going to go into this numerator. So if you recall from algebra, we learned how to take two fractions and combine them together by finding a common denominator into something of this form. But now partial fraction decomposition allows us to take fractions that are combined and decompose them into their original parts. So the way we do that is this follows the same exact process as how we learned to combine fractions together. So what we're going to do here is we're going to work on this side until it has the same denominator as this side. And then we can equate the numerators and try and solve for A and B. Okay, so first thing we want to do is get this side to look like this side, kind of. So to do that, we want to combine these fractions. We want to find common denominator. So we know the common denominator is x plus 4 times x minus 1. So in this first fraction, what I'm missing in the denominator is an x minus 1 term. So what I have to do is I have to multiply my denominator by x minus 1. And if I multiply the denominator by x minus 1, I'm changing the value of this fraction. So to undo that change, I want to also multiply the top by x minus 1. Now it's equivalent multiplying x minus 1 divided by x minus 1. It's equivalent to multiplying by 1. So I'm not changing the value of this fraction, I'm just changing the way it looks. Now over here, we want to do the same thing. So this denominator has an x minus 1 term. It's missing an x plus 4 term. I'm going to multiply the denominator and the numerator by x plus 4. Okay, so now this is kind of on a diagonal, but in this denominator, I have x plus 4 times x minus 1. I have the same thing here, x plus 4 times x minus 1. So I have a common denominator. And now I can combine these numerators together. So let's rewrite this again. X plus 4 times x minus 1 equals whatever is in the numerator divided by our common denominator. Right, so now our numerator is a times x minus 1 plus b times x plus 4. So, okay, so now we have here 5 divided by this denominator equals this whole thing divided by the same denominator. So for this equality to hold true, the numerators must be equal to each other. So this whole thing must evaluate to 5. So in that case, we can ignore the denominator now, and we can focus on the numerator. So we know for this to be true, 5 must have to equal this thing. Okay. So now we have basically one equation, two unknowns. The only way to remedy this is the fact that we have x's involved. And so what we can do is we can basically distribute this a in, distribute the b in, collect like terms, and then take another look and see what we can do. So first step was just distribute the a. We'd have ax minus a plus bx plus 4b. Okay, so now what we can do is we can collect like terms. So I can collect my terms of x's and my constant terms together. So I'm going to squeeze that down here. So I will have x times a plus an x times b, so plus b. And then my constant terms is just a minus a and a plus 4b. Okay. So now what we can do is we can imagine maybe I have an x term on this side. Now we know we don't have an x term, so I'm going to make the coefficient 0. That way we have 0 x's, but I'll write it in just so we can see things clearly. So now what we want to do here, to split this apart into two equations, we want to equate coefficients. So on this side, I have 0 times x. And on this side, I have a plus b times x. So for these things to be equal, a plus b would have to equal 0. So that's one equation that we have. So we have a plus b will have to equal 0. Now, if we equate the other coefficients, we have this constant term on the left of 5. And on the right, we have this constant term, minus a plus 4b. So again, for this to be equal, this minus a plus 4b will have to evaluate to that constant term 5. So that's another equation we have. Is 5. Okay. So now we have two equations, two unknowns. We can go ahead and solve. There's different ways to solve these types of problems. The easiest way that I see right now is that we can add these two equations together. So the way we add equations together is basically the way we add everything else. So I want to add this equation to this equation. So I want to add a plus b to, and let me not put my parenthesis there. To the equation above it. So basically what we do is we add everything on one side of the sign and we add everything on the other side. So this side we would have a minus a plus a. In that case, a's will cancel, so we'll have no a's left. And then we'll have a plus 4b plus b. So that would give us 5b. 5 and 6. And then on the right-hand side of the equal sign, we'll have 5 plus 0, which is 5. And in this case, we can go right ahead and solve for b, should be 5 divided by 5, which is 1. Okay, so now that we have b, we can either go back to either one of these equations, plug 1 in for b and solve for a. The easiest one would be this one. So if b equals 1, then a plus 1 equals 0, and therefore a equals minus 1. Okay, so now we found our coefficients, we found a and b, and now all we have to do is just rewrite. This is my a, this is my b. So now, instead of having this ugly thing, what we can do is we can rewrite this. So originally I had broken it up and decomposed it into a over x plus 4 plus b over x minus 1. Now we found our a is a -1, so I can just go ahead and replace a with -1, and b is 1. So b can be replaced with a 1. And now we've successfully decomposed this fraction into partial fractions. And that's basically it. Now in calculus 2, what we do is we take this, which most likely will be integrated like that. That's going to cause a headache to integrate. So what we do is we take this and we use partial fraction decomposition, which is algebra, to break it apart to two fractions that are much easier to integrate. So say we started with this and we go to integrate this new thing, which is the exact same as what we started with, just in a new form. What we can do is we can distribute our integral sign, or we can imagine that it's just one integral. And this form matches the natural log form. So if the natural log form is integral dx, or in this case, we could say du over u. So if u is my denominator, x plus 4, the derivative of that is a 1. So this is the form natural log. And indeed, if this was an integral, our answer would be minus from this constant term, natural log of x plus 4 plus the natural log of x minus 1. And then the plus 3. And we'll be done. So we start with this, which looks like it would give us a headache. And we break it apart using algebra into something simpler that we are much more familiar with. And that's the point of partial fractions. Okay, hope that helps.